Today we're going to talk a little bit further about conditionals, but we're going to add what we call truth tables into those conditionals. So we're going to learn what a truth table is, how it relates to conditional statements, and what are some more symbols used in arguments. So a truth table lists all possible combinations and truth values for a statement. So remember that a conditional is P then Q. Okay, so let's look at the truth tables for a conditional. So if I get a true statement for the premise or my hypothesis, which is P, I can get a true statement for the conclusion and I can get a false. And again, here's my false for my, falses. I can get a true and a false statement again. Okay. For one of these statements to be true, okay, or actually for one of them to be false, it's only going to be false when a true hypothesis produces a false conclusion. So I've got a true and a true, and that means that then my whole conditional statement is true. If my hypothesis is true and my conclusion is false, that's the only time I'm going to get a false statement. Okay? So even though the conditional is false in this third example and the conclusion is true, this still gives me a true statement. And even though both of in the last part here, even though both of those are false, the hypothesis and the conclusion, the whole statement is true. Okay? So this is really important to know that our final statement is only false when a true hypothesis produces a false conclusion. Okay? So let's look at the truth table for the converse. Remember, the converse, we're going to switch our hypothesis and conclusion. So we've got our key point. We're going to go backwards this time. This is going to become our hypothesis. This is the P is going to become our conclusion. So when Q is true and P is true, then the converse is true. When Q is false and the P or the is true, then this is true. When our Q is true and our P is false, because I've switched this and the T has become the hypothesis and the F has become the conclusion, it's going to be, my converse is going to be false at this point. Okay, and then because both of these are false, the Q and the P, this is going to be a true statement. So we did it backwards, but again, the only time it's going to be false is if this is true and this is false. Okay, that's the only time it will make it a false statement. So now let's look at the inverse. So remember, the inverse just negates the hypothesis and the conclusion. So if I'm going to negate P, this will be false, false, true, true. If I negate Q, that's going to become false, true, false, true. So now we're going to concentrate on these. Okay. Again, the only time that this is false is if not P is true and not Q is false. So the only time I have that is going to be right here. Okay. So this is a false statement, and all the others are true. Okay, and to review our symbols, we have the conditional, the if-then statement, so P, Q, or whatever we're using, it could be R and S. This would negate the statement, as would this. Therefore states a conclusion, and then the biconditional is your if and only if, where both your, and it can only be written where both your conditional and your converse are true. So here are some new symbols we have. This V means or. So this doesn't go to the truth table, this goes to a statement. So if you think back to Algebra 1 and you had absolute value inequalities, so this was an or you had compound inequalities, okay? An or would be something like this, okay? Where only one part can be true, okay? So in an or, one or both parts are true for a whole statement to be true. So this was your or statement, okay? If this is true, the whole statement is true. If this is true, the whole statement is true, okay? Then you have an and. Both parts of the statement must be true for the whole statement to be true, okay? So both the premise and the conclusion have to be true. And again, if you go back to our compound inequalities from last year, here was when, we can put it in here too, in order for that statement to be true, everything had to be true. All right, so we have the statements. You build it, they will come. So let's practice with our symbology. The double arrow, remember, means if and only if. So this is they will come if and only if you build it. The next question, the upside down V, is an or statement. So you build it or they will come. And the last is an and statement. So you will build it and they will come. Now this, in an if-then statement, P then Q, is from one of my favorite movies of all time. If you build it, they will come. See if you can figure out what movie that's from, and there might be prizes involved. And actually, it's a really great book if you want to read it and you're into, I'll give you a hint, sports movies and books. All right, so determine the truth value for each of these statements. So X emperor penguins are black and white. So that right away, we can say that that is a true statement. We're just going to start right there. Okay. Polar bears are an endangered species. This is true. And penguins wear tuxedos is false. Okay. So remember that in order for an and to be true, both parts have to be true. So X has to be true and Y has to be true. And in this case, that's true. So that means my whole statement is true. Emperor penguins are black and white and polar bears are an endangered species. The next is an or statement. And here's where it's weird. Sometimes people think, actually, no, we're good here. So both of them, only one of them has to be true. So emperor penguins are black and white is true. And polar bears are endangered species is also true. So that's going to be a true statement. Okay. X and Z. So we said that X was true and Z was false. So both of these have to be true in order for this to be true. So this is false. That emperor penguins are black and white and penguins wear tuxedos. And I said it got weird up here, but this is actually where it really gets weird. Okay, so if this is true and this is false, which we determined already, this is an or statement. Okay, so emperor penguins are black and white, or penguins wear tuxedos. First part is true, second part is false, but it's an or. One or both parts can be true in order for it to be true. So I've got one part true, the first part, so an or makes that whole statement true. Why I say it gets weird is common sense wants you to say that's false, but the word or makes it so that it's a whole true statement because only one part needs to be true. So this is not a truth table. This is just, so I don't want you to think that way. This is just a way to practice those statements. So what I would do is I would pause, okay, the video, do these statements, and then start the video again because I'm just going to throw up the answers. Okay. Then if you have any questions about them, sorry about that, you can ask me in class. So pause the video, try these, and then check the work. Here are your answers. Remember, if you were confused about dolphins, dolphins are not fish, they're mammals. Kind of a tricky question, right? But your teachers from last year, 7th grade, life science would be thrilled if you remembered that. So today you learned what a truth table was and how it related to our conditional statements, how to fill one out, and again, what symbols are used in logical, and we added and or. Remembering that or, only one part of a statement has to be true for the whole thing to be true, and an and, both parts have to be true in order for the statement to be true. So have a math-tastic day.